So I lived Philippines 2 years. That's my info. I'm that guy. I've dragged Ubertor through multiple platforms and then up to the current EC2 setups. I know a little bit about the topic. Oh yeah, and I'm the only sysadmin we got. And I'm not really spending that much time. So what does cloud ready mean? Well, that's very different from a clustered setup where you split up all the different pieces. And the other thing is cloud ready often means easy to deploy and easy to replace. How's cloud different from a regular server? Well, it's not one server. At least not usually. I mean, you could technically have a single instance of something running in the cloud, but that kind of defeats the purpose. It's generally considered less reliable, and its middle name is automation. So, not one server. Well, basically, your cloud deployments tend to be made up of lots of smaller servers. It improves your reliability. So if one server fails, it doesn't matter because you still got a bunch of other servers doing the job. Most of the time, it's not about taking over, really. It's like the servers are doing the work. One goes down, the other one just has to do twice the work now. But it's still okay. Well, like for a web application, you load a page and you load it again. Second request could go to a different server. Sometimes, say you're making a simple like file management app, you upload a file on one request. On the second request, you want to retrieve the file, but it's not there because you're on a different server. Caching is just well, think of it this way. So you have an app, and it say it for all intents and purposes. Let's say it's a file storage thing. So you upload a file, and it goes to the server. And it's not cloud ready, so you've just dumped the file into a folder, and you're like, okay, great, it's done. But then you have two servers working in parallel, so your first request went to one server, we put the file on the server, then you go to a second request, and you're like, where's my file? Oh, it's there, it's on the other server, but I can't get to it. Right? So let's take a big company as an example, Google. Every time you do a query, odds are you hit a different server. So search, you probably went to 3 different servers in their cluster. Just because it spreads out the load.
Or distributed.
If there's multiple servers, then you can is evenly distributed between all the different servers, right? So it doesn't matter who you are, where you're connecting from. You have an equal chance than everybody else to just hit any of the servers. So all the servers on average get hit about the same amount of times. That spreads out the load pretty evenly. That's star because technically you can set up your load balancer to be sticky. So you can say, so once you start talking to one server, your load balancer can favor that server and always send requests from this certain person over to that server. But that screws with your distribution, because now, actually, it's my best example. My best example is basically when, say you have 2 servers working on your requests, and they're pretty evenly loaded, but they're at their capacity now, and you want to add a 3rd server. So you got all these sticky requests going to the first 2 servers, and you add a 3rd server, what's going to happen? Nothing. Because all these requests are still they're sticky to the first 2 servers, so they're not going to see any performance improvement, because only brand new requests will end up going to the 3rd server. If they're not sticky, then the moment the 3rd new server comes online, all of a sudden 1/3 of all the traffic from the first 2 servers goes over to the new server. It is less reliable, but on a good note, if something breaks, odds are, you're on the same server as somebody else, and they've already complained, so your issue might already be being worked on. Also, it's managed by a big company, so they might have already noticed it themselves. Plus, cloud deployments tend to be cheaper, so it's easy for you to just get a couple of extra instances and build in redundancy into your setup. It takes time, it takes effort, and you don't want to have to build out a whole new server every time you need to scale up or down. So you want to set up automations. Like your cloud provider will have an API to provision new servers already. So why do you not have automated scripts that just brings up your server from a clean install to your production setup? Many cloud providers have already even facilities to help you boot up your ideal server configuration right away. So you can either automate that or even semi-automated, you know, like trigger a script. It's not building it out all by hand. An easy deployment, it kind of goes together with automation. If your application has a new version that you want to release, you don't want to FTP into each server, upload a new files. You just want to be able to run a script, goes to all your servers. You want to be able to bring up a brand new server, set up the way it's supposed to be set up, with your stuff already ready for it, activate the new server, take down the old server, done, right? You don't want to have to, again, build your replacement by hand. You don't want to have to build it by hand, right? So automation, easy replacement, it all goes together. So what are apps missing? Well, most non-cloud ready apps rely on your framework's default session handling. That's the thing that somehow makes each consecutive request somehow be associated with you. So say you're in an e-commerce site and you have a shopping cart. Well, you reload the page, you still have your shopping cart. That's done through sessions. Basically, it just leaves a cookie on your browser, and it can retrieve your session record from, well, wherever it stores the session. Rails, for example, by default now uses cookie-based sessions, so it's a better default than the old default. It automatically is able, because it stores all the session data encrypted in a big cookie, so it's always there. It always comes with the request. PHP default session handling sticks a whole bunch of files in a temp folder. That doesn't work very well across clusters because your session data is not available on two different servers. So, and then most non-cloud ready apps tend to rely on being able to write to a folder and dump a bunch of files there. I mean, even like, say, for example, WordPress in its default setup relies on uploading files to a folder. So any like attachments you have to your blog posts, it dumps them into a folder. So it means basically it's not cloud ready. You can't stick it on two different servers if you have lots of load going through your thing, and because your images won't be available on the other server. So yeah, your session's stored on the server. You know, you'll not be able to share them between different servers. Files uploaded to only one server, then you'll not be able to see them on the other server. Modify your app to put the session data up in a database, and all of a sudden, all your servers are able to access this data all at the same time, right? So it doesn't rely on sticking files in the thing. Uploaded images and stuff can be sent to a central file server if you have one, or a stored server such as Amazon S3. SAN is just a specialized case of a file server. It's a fancy, big, complicated file server. What about databases? Well, it normally has to be separated out as well. Again, it doesn't have to. You can stick it alongside one of your application servers, but that messes with your resource allocation, because all of a sudden that one server isn't able to handle as much. And if it gets busy, your database server gets affected, and the other server gets affected because of that. Ideally. I'd say you could compromise by putting it on your load balancer, for example, because load balancers don't really get that much load. Load balancers load. They don't know, like it's a really trivial process to take a request and forward it on to your actual application server. So load balancers actually pretty much run idle most of the time.